Topic 3 looks at the constructs, variables and data types. The subtopic are firstly constructs and variables. Secondly, independent and dependent variables. Thirdly, moderator and extraneous variables. Fourthly, operational definitions of variables. Lastly, types of data in quantitative research. Constructs are theoretical concepts that are used to describe specific attributes such as intelligence, motivation, self-esteem, reading comprehension performance, and customer satisfaction. In research, a construct is loosely referred to as a variable. That is something that varies because it can take on different numerical values or classification labels. Examples of variables are IQ, which has a score of between 50 to 150. Comprehension performance, which has score of between 1 to 100. Gender, which is categorized as male or female. And SES, socio-economic status, which can be classified as low, middle or high. What is the difference between independent and dependent variables? An independent variable, IV, is the variable that is presumed to cause a change in the dependent variable, DV. An example of an IV is teaching method and a DV is academic performance. The IV, which is teaching method, can be manipulated, that is, divided into discussion method and lecture method. Other examples of IV can be manipulated as gender, male or female, and socio-economic status, high, middle or low. The DV, academic performance, is a score or outcome and cannot be manipulated. Other examples of DVs are IQ scores, attitude scores, and self-esteem scores. Can you identify the independent and dependent variables in the following research in the following question? You are interested to find out if students who are exposed to project-based method, PBM, will perform better in the science subject than those who are taught using the traditional lecture method, TLM. Besides, you also want to know if PBM would change their attitude towards learning science. Lastly, if PBM has positive effects, you want to know if it would benefit A. male students more or female students more, B. high achievers more or low achievers more. With reference to the foregoing question, the independent and dependent variables are represented in the form of a diagram. The first independent variable is teaching method, which can be manipulated as project-based method, PBM, and traditional lecture method, TLM. The second independent variable is gender, which is divided into male and female. The third independent variable is level of achievement, which is categorized as high and low. On the other hand, the dependent variables are the outcomes, academic achievement, and learning attitude. Gender and academic achievement have been included in the study to find out whether they would modify or moderate the cause-effect relationship between the PBL and performance in science, as well as attitudes towards learning science. They are, therefore, a special type of independent variables or known as moderator variables. It is also important to take note of another type of independent variable called extraneous variable. An extraneous variable is an independent variable that may influence the outcome of a study but has not been taken into consideration in the research design or has not been controlled. For example, in the study on the effects of project-based learning, PBL, on the students' performance in science and attitudes towards learning science, one independent variable, that is, language proficiency of the students, has not been taken into consideration. If the PBL consists of students whose language proficiency is better than the traditional lecture method TLM group, And when the finding shows the PBL group outperforms the TLM group, the better performance could be attributed to higher language proficiency of the students. One way to control an extraneous variable which might influence the results is to make it a constant. That is, keeping everyone alike on that variable. For example, the researcher can restrict the study to one proficiency group of students, such as average proficiency level. In so doing, he can eliminate language proficiency as an extraneous variable. The variables or factors in educational research are continuous variable or ordinal variable and categorical variable or nominal variable. A continuous variable is capable of taking an ordered set of values within a certain range, such as 1, 2, 3, 20, and so on. Examples of continuous variable are temperature, height, weight, attitude, score, achievement score, etc. A categorical variable is a measure of difference in type, not number or amount, providing label classification. Examples of categorical variables are race, which can be classified as Malay, Chinese, Indian, and others. Gender, which can be classified as male or female. Socioeconomic status, which can be classified as high, middle, or low. And proficiency level, which can be classified as good, average, and poor. Let's move on to the operational definition of variables. Variables used in a study must be operationally defined as they are used in the context of the study. This is especially important when they have different definitions in different contexts or when using them in a way different from the commonly held definitions. Clear operational definition of variables will eliminate confusion. Variables need to be operationally defined to facilitate measurement. Not all variables are directly observable, thus they cannot be measured directly. For instance, we cannot observe and measure learning directly, but we can see its effect on performance. So if we give a test to students after a learning process and their performance improves, we conclude that learning has occurred. When we talk about operational definitions of key terms, especially the variables investigated in the study, we should be aware of the distinction between a constitutive definition and an operational definition. A constitutive definition is the dictionary type of definition. It helps to convey the general meaning of a variable, but it is not precise enough for research purposes. We need to define the variables so that readers know exactly what is meant by the terms and that other researchers can replicate the research. This is only possible when the operational definitions are provided. There are two types of operational definitions, namely measured and experimental. A measured operational definition details the operations by which researchers measure a variable. For example, intelligence may be operationally defined as scores on the Stanford Binet Intelligence Scale. On the other hand, an experimental operational definition details the steps a researcher takes to produce certain experimental conditions. For example, the operational definition of concept mapping strategy in a reading research study may take the form of a group of students reading text with the help of concept maps, experimental condition, and another group of students reading text without the help of concept maps, control condition. There are 4 types of data in quantitative research. The first type of data is nominal data, which takes the form of frequency count. It can be expressed in percentages, such as the percentage of students who passed or failed in the test. The second type of data is ordinal data, which is stated in the form of rank, either from the lowest to the highest rank or vice versa. An example of ordinal data is ranked scores. The third type of data is interval data, which has a value on a continuous scale but does not have an absolute zero. Examples of interval data are scores such as test, exam, attitudes, and IQ scores. The final type of data is ratio data, which is also measured on a continuous scale, but it has an absolute zero. Examples of ratio data are test and exam scores, age, height, weight, money.